Hello and welcome. In this video I'm going to make some procedural dice in Houdini. In this video I want to talk a bit about using loops and using a bit of Vex to sort of like enhance your workflows. These are essential tools that will be important to learn more about Houdini. So let's get started here. So the first thing we want to do is place a geometry like a platonic shape node. These will create some interesting shapes. So we can go in there and this gives us this shape. We can already use this for a dice, but we can also change the shapes to something else like this or this one. And we can also, of course, have a basic cube if you want to, like here. So the idea here now is that I'm going to loop over each primitive, and I want to get the number of the primitive to use as my amount of dice number. So with our first step, I want to now get these numbers, like I want to visually see what's going on and get numbers on primitives. So in Houdini by default, I can enable now these numbers, and as you can see, I have a number for each primitive. This is a default. What's going on in the background is that each primitive has its number, as you can see here. This is very useful to know, and we're going to use this or leverage this to then create a specific amount of number for each primitive or side of the dice. So with a platonic shape, what I want now is to loop over each primitive. So I want to loop over each primitive or polygon, and then you try to use the number to then actually assign a number or cut a number in the surface there. So this is very useful to do with a loop. So let's place a for each loop. So you'll see that there are multiple options here, like connect pieces, named primitives by a certain amount of numbers. We can loop over the points, we can loop over primitives, which we're going to use, and we can also loop with feedback. So these are quite useful to have. So currently I'm going to use loop over primitives. So if you plug that in over here, and we will now loop 6 times. So we have 6 primitives, so we will loop 6 times here, so we can see the number. And what's also interesting to know here, currently we are not actually connecting the surfaces together. So because of the loop, the points are now separated. So we can see that I have 24 points, but my original mesh had 8 points. So that's important to know, is that if we loop over a primitive, we will one by one split sort of like the primitive and go over them. So the loop will just only like, not really like stick them back together, we'll just merge them back together. So a quick example here is we can, for example, do an extrusion here, like a very basic extrusion. And the loop will then repeat that for every primitive we input. So of course, you don't need to do this in a loop, you can do this without the loop, but this is just one example of what a loop is doing. It's just going to repeat the process for each primitive that we have here. Also interesting to know is that we can also use a single passing feature here. So if you want to individually see a certain number, like number 0 or 1 or 2, we can then use this to like visually try to get a certain number. So this can be very useful for visualizing and debugging certain numbers. So only here I can go up to 6 because I have 6 primitives. So very useful feature. But now I want to use that primitive number that I had here, and I want to use that in the loop. Now, since we loop over each primitive individually, we would like to store the primitive in the attributes. So here we have attributes. You can also open it on the side here. You can also split your Houdini views if you're interested. You can split that. But I always like to have a geometry spreadsheet at the bottom here. Talk about adding a primitive attribute. So we have different amounts of attributes, but currently we are working with primitives, so let's take 2 primitives. So currently I don't have any attributes there. So if I do in my loop, it's only going to say 0 and nothing more. So I don't really have a lot of information there to use in my loop. So now I'm going to place a wrangle node. So the wrangle node will be a little bit of like coding, like it's a small language you could use to drive certain attributes or do a certain function. So first of all, we need to set the right context. So again, I'm going to work with primitives, and we want to run this wrangle or this code over the primitives instead of the points here. So it's always a good idea to think what you're going to do and set this accordingly to what data you want to work with. So here I want to work with primitives, so I want to store primitive values. Now, how can I save an attribute here is we can just say add. So add my value equals to, for example, 1. And then when we go out of this, we will have the value my value. So this is how we can write a value or overwrite or read values. So this is very important to know, and this is a very basic Vex here. And this is a very basic example. We can also make this into an integer. So right now it's a float. So if I type in I in front of it, we will actually make this into a integer. So as you can see now, it's actually now a integer. This is how I can make custom values. So if I can also type in an S for string, and in here we can then of course need to give it a string value and have to say something like this. So we can keep the 1, or we can also add some text like test and so on. So this is how, again, how we can basically write a attribute. If you need something, we can just use a line of code to have that. So, but now I want to use that primitive number. So each primitive has its number and would like to have access to that. So I can say add the numbers for my dice is equal to, now I'm going to use a function Houdini knows, add prim num. So Houdini by default knows this, and it will get for you the primitive number. So as you can see, we are just basically having the primitive number as a copy. And we can also do a I in front of it to make it an integer. So now we have just 1, 2, 3, 4, 5. And what we also see is that, I mean, if we have a dice, normally they don't start from 0, so they start from 1 to 6 here. So what we can simply do is do a +1, and then we have that. So you can see here that we can play around with sort of like what we have as a result. So we can do certain functions like random, we can do subtraction, multiply, and all kinds of things. So we can do a lot of things here in Vex, sort of like math related, to quickly handle some data of attributes. So now if we go back to our loop, we have that number, and if I go to my single primitive here, or the first or the last loop here, we can see that my number is equal to 6. That's now very useful to have in this network. So now let's use that number and print it out in a font node. So the font node will just print out text. So if I would type in a certain text like test, it will just print it out in our viewport. So now I want to have the data from that primitive into the font node. So this is something that can also often happen in Houdini, is how do I transfer data between different nodes? So there are a couple ways of doing that, but what I would like to do is use the spare input. So I'm gonna go here to the settings and I use a spare input. So all the way at the bottom, we basically have a slot here for a node. So I can drag the node in there, and now I have a spare input. So they are sort of like linked to each other, but not directly. So with those spare inputs, I'm going to use a certain function to then read the value from that spare input. But before I start here, we need to type in something special, because we are now just converting text into geometry. So we need to use the code accent here, and then we can actually type a function for reading the primitive data. So I want to read that primitive data. So if you don't know what you're doing, you can always like look up the documentation. So here we're going to use the primitive expression, and the primitive expression works as follows. So we're going to just type prim, and then we're going to give it a surface name, which will be the spare input. Then we're going to use the primitive number, and what attribute are you looking for, and what is the index attribute value. These are the 4 values you need to give in. So now let's just type in here prim. Then we need to say -1, and -1 means spare input. So if we type in 0 means itself, -1 means look at the spare input, so -1. Then we need to say what primitive, which is just primitive 0, since we are working in the loop, so just look at the 0. then what attribute do I need to access, which is just called number. So make sure you are using this in a string context, so number, and then also the index will be 0, and then close off that as well. And now you should see the value popping up here. So again, here -1 is the spare input, 0 is the first primitive, and number is our attribute, and then index is 0. So here, if I look to my primitive, we are looking for primitive 0, get the attribute number, which is 6. So that's what we have. So let's merge that or view that here in our output. And we just basically are stacking up the numbers on top of each other. So it's working, but of course we want to like space out or align the numbers with the primitive. So here I have the number, and if I look at my primitive, I want to sort of like copy paste that on that surface. So I'm going to use a copy to points. So first of all, we need to get the direction of the primitive. So where is the primitive facing? And we can just use a normal node for that. So we can plug the node in. We can set this to points. So we have a point direction here. So we can see what the primitive is facing. Then I'm going to use a fuse to extract the middle point here. If we just set this to a high range, we basically have nothing, but we have to disable some of the settings, like here, remove the unused points. So we actually have that middle point. So this is what I want to use to copy my number on. It can also be a good idea here to then disable that other setting to affect the normals, just to make sure we're not like changing the normal. Now, next step is just using a copy to points. So we can just say copy to point, and we can copy the geometry on that point, and normally this should work without any problems. So we have that exactly in the middle there. So now this is my new output. So if I look at that, we can see that we have now these numbers nicely aligned on those surfaces. So now the next thing to do here is then, for example, using a Boolean, and we can then Boolean the number with our original shape, but we also need to thicken the shape. So these are just 2D surfaces, so we want to like give it some extrusion. We can also do both sides here, so to make sure they are going to Boolean nicely. We can also lower the details of the font node, because the font is quite high in resolution. So we can go back to the font node, and we're going to change here then our level of detail to something a bit lower. And now this will probably be faster in a Boolean. So if I use a Boolean node, and our first input can be our base shape, so our platonic shapes. And then our second input can be then here that thicken. So now we have this as a result. So this already works really well. As you could see, we already have some results. So if I play around with the thickness of that node, we can then of course change how hard the shapes are cut in there. So this is what I currently have. We can also do a bevel on the box or on our input here. So this will make it a lot nicer. So we can do a bevel. We can go even quite extreme in this case. And we will have this as a result. So this looks like a nice cube with the numbers here. This is what my current result is. My system is working really nice. I can always go back and forth between the font node and, for example, change the font size into something smaller. Like you can type it to 0.5 and then you have something smaller in there. So now the cool thing is I can just also go back to my main shape and change that. So they should all work. So it's just printing out basically the primitive number and cutting it into the surface. As you could see, like it's just giving us that value. So it's just very useful to like get your first steps into learning with loops and a bit of Vex here to sort of like get that information. So this is basically what I wanted to show you at the first part. So now I'm gonna go into like sort of like the second part of this video, which I will go take a deeper look into Vex to actually make a dice. So here we're gonna take a cube, and from that cube we're gonna make a dice that looks like this. So how am I gonna do that? So there are of course many approaches on how to do this, but I want to use a sort of like a system that automatically knows a bit on what to do when we input a certain number of a face. So first what I'm going to do is I'm going to place down a grid, and in this grid enable the points or the wireframe. I want to make a layout for the dice we want to make. And so in the rows and columns we're going to say 3 by 3. So if my number is 1, I select the middle. If my number is 6, we're going to select these 3 on the outside. So I'm going to write a simple logic that automatically selects points based on what number we have. So next up, I'm also going to make sure this also nicely is placed in my world. So to make things easier for me, I'm also going to change the size to 2 by 2. And the reason for that is it nicely aligns with my grid, as you could see here. It nicely aligns with my grid spacing. So we're actually hitting number ones and number minus ones. So if I look into my attributes, like they either are perfectly 0, 1, or minus 1. So we have like consistent values to work with in our logic later on. Now I want to compare this grid and delete the points that I don't need based on sort of like the number we have from the primitive. So currently if I have number 6, I only would like to have the outside points here. So we're going to use a wrangle for comparing the values. So our first input will be the grid, and our second inputs can be here or loop input. So we have that now available. So again, here we want to think about in what context we want to work, and I want to work with points because I want to select or remove points based on the primitive value. So that brings us also the question, like we want to work with points, but we also would like to have primitive values. So we can actually use the similar function that we had here, but in Vex. So we can make a local variable here, which is called, for example, the current number. So current number. This is then equal to the primitive. And here we should get some more help. So this is actually a Vex primitive function, which is different from the one that I used from the font. So here we are using geometry, the name, and then the primitive number. So the geometry is my second input, which is 1, since 0 is always itself. Then we want to look at what value or what is the name, so number. And then, of course, what primitive number is 0. And that's basically it. So that should work. So we have that value now available. So if we want to print this out, we can then say add value equals current number. And if everything went right, we can now see this value over here. So make sure you're not making any typing mistake. So if I, for example, would do this, we will just return 0. So make sure you are consistently with that. So now we have this value here available, and we can start comparing the values with each other. So let's start from scratch with the first dot. So I'm going to go to single pass and start from number 0. So normally now our value should be number 1. Let's try to clarify what we're going to do. So I'm just going to write an if statement, and we're just going to say, like, if this is equal to a certain thing, then we need to add or remove points. So currently my input will be number 1, and number 1 is always in the middle of the dice. So we can just say that if the points are not equal to 0, then we can delete them. So let's do that over here. So we can use an if statement. So if, for example, let's copy paste then that number. So current number is equal to 1. Then when it's equal to 1, then we can say that we want to delete it based on the position. So if, now let's maybe use the short version of if. So if at the position of the point, so this is at P, so at position. So if I go here to P, this is the position. We can then say that if they are not equal to then 0, so we can say here 0, 0, 0. Then we need to remove the points. So remove points, and then we say from what geometry and what is the point number. So currently we want to remove from 0, so the grid. And then we want to say it's the current value, which is then point number. And let's close that. And that gives me already the result. So if my value is 1, we will only keep the middle point. So now what we can do is we can just copy a sphere on that point, copy 2 points, maybe make it a mesh, so polygon mesh, maybe make it a bit smaller. So then we can use this over here actually. So it's actually now aligned. So if I do my full loop here, and I don't need to do the extrusion, we will basically then sort of like Boolean out this dice number, so you actually see the number of dots. So then let's continue by going to the next pass, which is then number 1. So this is then number 2 in the background. So for number 2, what we can do is we can try to again come up with some sort of math formula. So what I can say is that if the x and y position are equal to each other, then we could remove them. That will already give us these 3 dots. But then here we can also say, then also make sure you're also removing that middle point. So now let's just basically copy what we have here and paste it. So if my current number is 2, then let's also just remove this for now. I want to get a certain position based on the x and the z in this case. So we are looking at x and z, not the y axis. So that's important to know. So if you remember, I'm going to compare the x values. And you can just say, for example, if they're not equal to each other, so if x and z are not equal to each other, let's see what this gives us. So we now have these 3 dots, so this line. So this is then my result. And I can just say here, or delete the middle point as well. And I'm going to copy paste this from here. And I'm just going to say if it's equal to that. So now we only have these 2 points. And again, we are placing then a sphere on that. So at this point, if you want to practice this, you can try to do the other ones, the other 6. So it's a good practice to like build up some of these things by yourself as practice. But I'm going to now go a bit more quickly over them. So here again, let's just copy paste this. And for number 3, we're already pretty close. We only have to basically delete this here, and we have those 3 dots. So let's move on to number 4 then. So number 4, and again, we can just copy paste what we have. What I'm going to do with number 4 is I'm going to get the absolute values of the numbers. So what I can say here now is absolute value of the x and compare it with the absolute value of the z here. And now we have these 4 points. So that's already working as well. So let's now move to number 5 here. So for number 5, let's copy paste number 4. So 5, and we're going to remove this part of here. So we have number 5. Then we have the last one, so number 6. So let's copy paste this here again. Number 6. And now what we can do is we can say at point.x is 0. So every position here where the x is 0, we will remove them, and then we have 6 dots. So now I'm done, and if I look at my results, it's not really looking that nice because they are actually too large in this case. So I'm actually gonna here place a transform in the middle. So here, after I calculated what I needed, I can now, for example, easily scale this down like so. And also noticing here that our rotation is not correctly. So let's rotate this 90 degrees And now we actually have that proper result. So we have these dots here. So I can now fine tune it a bit more. I can make the spheres a bit larger if I want to. So we can have larger ones. And that's basically how you can create something a bit more procedurally with some Vex knowledge in there. So again, these were very basic examples, just sort of like a more introduction and practice. This is just for you to get some idea and get used to using certain functions, like how do I get a primitive value, how do I use the if statement, how do I get the position, how do I remove points, how do I, for example, get the absolute value, things like that. So these are just very basic things I explained you here, just so you can get some idea here. So that's basically what I wanted to show with this video. So again, you could make some more improvements, like you could do an automatic switch here, like you can automatically switch between the font and our system for placing the dots. You can also place the ticken back over here, so we're not conflicting with that. So yeah, so you can write a certain logic here, which is very similar to basically what we had over here. So we just get the primitive, and if it's equal to number 6, then we're going to switch here that number, so we can automatically switch that if you want to. If you're really interested in learning more about Vex and VOPs, I can recommend you checking out CG Wiki with the Joy of Vex series. Feel free to like, subscribe, comment. Thank you for watching.